Welcome back to my channel. This is Kedomuju from KD Concept Researchers. Please kindly like and subscribe to our channel so that you can always get our videos while it drops. Now, the primary objective for this work is to fit a regression line to see the impact of these four variables on nominal GDP. Now, how do we do that? Let's go back to the slides. Now, to be able to do that, we'll be conducting correlation and regression analysis. Now, put it simply that correlation and regression analysis are the most commonly used techniques for investigating the relationship between two or more quantitative variables. Please pay attention to this. They must be quantitative variable. That means there must be numerical values attached to these quantities which want to check their relationship. So that is what correlation and regression analysis does. This is just giving you an overview. Okay, now we have the general regression model, which is stated here. We have y equals to b0 plus b1x1 plus b2x2 plus up to bn xn plus e. I'm not going to bore you so much of this formula, but it's always good for you to know how this formula is stated, so that when you fit your model, you can be able to interpret the result you have obtained. Now, y represents the independent variable. That is the value we wish to predict. Y x1 up to xn represent the independent variable. These are the regressors or the predictors. Then b0 is the constant of regression. Now, this constant of regression is very important in regression analysis because it gives us the value of the dependent variable when the independent variables are all equal to 0. So that gives you the constant of regression there. Then b1 up to bn represent the coefficients of the regressors. That is the quantity of each of these regressors that will be used in the model. And of course, our E is the stochastic error term, because no regression model is perfect. There's always a difference between the actual value and the predicted value. So that is what this E takes care of. Now, in the next slide, we have a very simple model here. This is our simple linear regression model, where you have one dependent variable and one independent variable. If you look at this one here, you find out that the number of independent variables ranges from x1 up to xn. So it is more. So this one is a multiple linear regression. While in this other slide here, this is just a simple linear regression because it has one dependent variable and one independent variable. And a good example of the data that can be used to fit such model is this. We have here width, and then we have height. And now we are to fit a regression line of width x on height y. Please pay attention to how it was stated. We are fitting a regression line of x on y. That means height becomes the dependent variable, while width becomes the independent variable. So also correlation, which we'll talk about mainly tomorrow or maybe even later this night. We can use correlation coefficients such as Pearson product moment correlation to test if there is a linear relationship between variables. To quantify the strength of the relationship, we calculate the correlation coefficient called R. And of course, we need to square it to get the R squared. That gives you the power of the regression, telling you how well the independent variables have predicted the value of the dependent variable. So the R value ranges from plus 1.0 up to minus 1.0. Now, when the R is greater than 0, we have it indicates positive linear correlation, while when it is less than 0, it indicates negative linear correlation. But when it is 0, it means there is no linear relationship between those data points. That's the worst case scenario. Now, it's also worthy to note that when the R square is, when the R, of course, is square, the R square is greater than 0.5, that is where we have a strong positive linear correlation. Down here, we have, of course, the mathematical formula for computing the R. when you have your two variables. I just have to state this here because this is what Excel will actually be doing for us. We're using this formula to make some numerical computations to give us results. So quickly, let's go back to our Excel. Now, I have this first data here. Sorry, I could not add this one, but it's very simple. Those on their system can type it. Let me zoom it. Let me zoom out a little bit. Okay, I think it's big enough now, can see. So we have this data here. The first column is for width, the second column is for height. And now we wish to fit a simple linear regression line of width x on the height y. So let me put here, this is our x and this is our y. Now, before we do that, there's something that is very important which we must do on our Microsoft Excel. If you're on your system, go to your data menu. Now, if you click on data menu, if you observe on my own system, on the right end here, you see data analysis. This may not be so in every Excel. By default, it is not active. So it is the user that will have to activate this instruction called data analysis. And of course, I've written the steps on how to activate it in the PowerPoint, which I will send at the end of the class. So quickly, how do we activate the data analysis? Because it is from here, let me click on it. It is from this data analysis that we can conduct advanced statistical data analysis, such as regression analysis, correlation analysis, t-test, z-test, f-test, and the rest of statistical tests. Let me click on it. Hold on. Okay, now if we click on the data analysis, this dialog box comes out. As you can see here, we have ANOVA, two factors, correlation, exponential smoothing, f-test, histogram, moving average, rank, regression, t-test, and the rest of them. Now, the question arises, how do we activate this menu? So quickly pay attention as I show us how to activate this data analysis. You can do it alongside me if you're on your system. So quickly click on File. If you click on File, you're going to see Option. Option may be the last thing on the list here. So you click on Option. From File menu, you click on Option. Now, second to the last thing on this Excel option is Add-ins. You click on it. Add-ins. And then allow it to load. Save instructions, so it will take a while to. Now, from the add-ins, you see Manage. Under Manage, there are so many add-ins that can be selected, but what we want is Excel add-ins. So I will select it and then click on Go. Now, when you click on Go, another dialog box appears. Adding you, which add-ins would you like to add? As you can see, I've added Analysis 2-pack, Analysis 2-pack, VBA, and eViews, and some other ones here. But the most important one which activates that data analysis is the Analysis 2-pack. So this is the one you're going to activate. This Analysis 2-pack, just select it. You can leave the rest, and then you OK it. Once you OK it, you allow it to load, after which data analysis will appear. So that's simply how to activate the data analysis 2-pack. Now, quickly, the first thing you may want to know about these two data sets here, these two columns, is their descriptive statistics. What are descriptive statistics? These are the mean, the median, the mode, the counts, the range, the minimum value, the maximum value. So that is the descriptive statistics. That's the first thing we're going to do to this data. So to do that, I'm going to highlight the data, then click on my, assuming I was at home, so I'll click on Data, then I'll click on Data Analysis. Now, I can see descriptive statistics. If you can't see, just type D on your keyboard. It will automatically take you to descriptive statistics. Then I will OK it. Now, again, it's asking me to select my input range. Input range includes the entire data range. So I will highlight it. I will highlight just my entire data range. Okay. Again, remember, since I highlighted the captions, that's the data label, I'm going to tick this here, which says label in first row. So I'll click it. Now, down here, it's asking you, where do you want this your output? I want it on the new sheet. I will select that. Okay. Then I will OK. Okay, we'll have to choose one of these statistics here. So I'll just choose summary statistics. Summary statistics on a new sheet. Then OK. Allow it to load. Good. Now we have our result. Let me zoom it out. We have our result. Now, this is the output gotten from checking the descriptive statistics of this given data set. You can see the mean. The mean of width is 174.714, while the mean of height is 68.148. We also have the standard deviation. Of course, we know that the most important descriptive statistics for any given data is the mean as well as the standard deviation. However, every other one here is also important. You can see the counts showing that the data points are 7 in number. And these are the sums, the minimum values, the maximum values. Good. Excuse me. Now, let me come back to a bigger data set. Look at this data set. This data set has about 1, 2, 3, 4, 5 columns. I can also check for the descriptive statistics of this data by simply going back to my data analysis. Please, we'll have to do 2 sections for tonight. The time is already running out because we started late. So we'll do 2 sessions for tonight. Thank you. Now I'll click on data analysis, select descriptive statistics, and OK. Now inside this input range, I'm going to remove whatever that was there and then come back to my data and then highlight the entire data range, including the first row, which is their captions, the data label. So I will highlight the entire data range. Remember, I will have to mark label in first row. And this data, very important, is grouped by column. They are not grouped by row. The group is by column. So we have column 1 to column 5. Of course, everything is set, summary statistics, then I will OK. Good. Now we have here the descriptive statistics for these given data points. We have the mean. Maybe I can just highlight this, double click at any sentence so that it opens it fully for me to see. Now we have the descriptive statistics for nominal GDP, demand deposits, credit investor. So with this, excuse me, we can compare the mean side by side, the mean performance of each of these variables, and also their standard deviation. This is the first thing we want to do to check what is happening to the given data points. Okay, now leaving this, now remember you have to be saving with Control X. For any new output you have, you save it with Control S. So I'm going to come back to my regression analysis. Remember, the objective tonight is to fit a regression model. So let me go back to the simple data, simple regression there. So I'm going to fit a regression model of X on Y. Now, how do we do that? Very simple. We still have to go back to our data analysis. Now, this time now, I'm going to choose regression. So I'll type R. R will take me to regression. Then I will click on OK. Now, this is the regression analysis dialog box. We have the input variables, input Y, which is our dependent variable. So I'm going to select the Y column here. Then input X, I will select my X column. the entire data range. Then remember, we have to click label so that our labels are also added. Of course, I want my output to be on a new sheet. Remember, you have to input your y variable into the y, x variable into the s space provided here. As you can see, once you do that, you see that the x column is selected. Then I'll click on OK. Now, this is the output here. This is the output. First, let me expand this column so we'll see what's happening here. We have the regression statistics, our R, then arrow square, adjusted arrow square. Let me zoom out this area. Now, this model performed very well by looking at the arrow square here. The arrow square is 0.9, which is about 96%. So it shows that the independent variable predicts the dependent variable up to 96%. That's why we have our arrow square being equal to 0.96. This is a very fine model. Now, to support this arrow square, we have our regression ANOVA here. If you look at this second table where we have ANOVA, you see that this is a significant model. Now, the regression ANOVA is simply stating that there is no significant difference between the two variables. That is, the predicting variables does not predict the dependent variable very well. But considering what we have here, now, we see that this test is significant because the F statistic is giving us a significant value of 0.0004, which is far less than 0.05. Now, in statistics, we have two popular levels of significance. That is 5% level of significance and 1% level of significance. Now, this value here is both less than the 5% level of significance and also less than the 1% level of significance. So it is highly significant, which shows that the model is good. Now, the third table we have here is table of coefficients. This is now where you get the values for the model. You see the intercept. This intercept is that constant value, of course, while this one now is the value of our independent variable, the coefficient for our dependent variable. So this is our beta naught and this is our beta 1. So if I want to write this model, I can simply say this model is y is equal to 32.783 plus 0.2001x. So this is simply the model we have here from this table of coefficient. And also, if you look at the p-values of the coefficient, you find out that both coefficients are statistically significant, because sometimes there are some models where some coefficients may not be significant, therefore they will not be added in the model. So the p-values for these coefficients are significant. That means this model performed adequately well. Now, let us also look at the second data we have here. Now, in this second data, the first one we just did now is a simple linear regression. This one now is a multiple linear regression. Multiple in the sense that the predicting variables are more than one. We have 4 predicting variables here, which will be predicting the value of the dependent variable. Okay. Now, we should be predicting the value of the dependent variable. Now, how do we do that again? Remember, we'll go back to our data, then we'll go to data analysis. Of course, we select our regression and OK. Now, of course, you know that our y input is always one column. There is always one dependent variable. It is the independent variables that can be more than one. So again, I'm going to select nominal GDP, which is our dependent variable. I will select it completely. Then in our x variables, pay attention to what I'm going to do now. Now, this time around, I'm not going to select just one column, but the 4 of them. I will select the entire data range for the 4 independent variables. I will highlight them completely. That will be our x range, covering from the second column to the 5th column, giving us 4 independent variables. Having done all that, I will ensure that my data label is ticked and also that my result is going to be pasted on the new worksheet. Then I will OK. good. Now, this is the output of the multiple regression that we just conducted. Again, this model is good because I can see the multiple R here is 0.9. Of course, the R square is 0.8. Now, let us note that in multiple linear regression, we usually use the adjusted R square. And of course, the adjusted R square has performed very well, which is about 0.86, showing that the predicting variables have predicted the dependent variable up to 86%. Now, this is also supported by the behavior of the regression ANOVA, which is significant. This is 2 point, this significance is 2.8 exponential minus 90. This value is very small, which is about 0.000002. So this value is highly significant. Again, let's look at the results of the regression model. If you look at the coefficients, first we have our intercept, which is our beta naught. If you look at the p-value is not very significant. So this constant term is not significant. But look at the coefficient of x1, which is demanded deposits. The p-value is also not very significant. Now, the one that is very significant here is money supply, which is having a p-value of 0.001664. Now, this simply shows that although the model is good, but only money supply has a very significant impact on the overall performance of nominal GDP. So that is how this regression model has performed. Now, so thank you for watching this video. You can also check out some other videos that are prerequisite to this one on our course series in data analysis using Microsoft Excel. Please kindly leave your questions in the comment section and we'll attend to them. Also remember to like, share, comment, and most especially, please kindly subscribe to this channel so that we can always serve you better. Thank you.